Okay, to do this proof, you have to be able to use some absolute value theorems or theorems on absolute value. And here's one that might not be so obvious. The absolute value of A minus the absolute value of B is guaranteed to be less than or equal to the absolute value of A minus B. I just put a couple examples in here to help visualize. So here in this first example, 10 minus 3 is 7. And over here on the right, we have the absolute value of negative 13, which is 13. 7 is less than or equal to 13. And for the second example, we get a negative 7 is less than or equal to 7. Okay, so that's just two examples, but we're going to use that theorem later in this proof. So here's an application of the mean value, or here's a graph of what's happening. Here's the point 0, which is on the function. And then let's pick any other point on the number line because we're differentiable on the entire interval of real numbers. So if we pick any x, then this point on the graph is f of x. And the mean value theorem says if the function is continuous on the open interval from, in this case, 1 to x, or on the closed interval, it's continuous on 1 to x and differentiable on the open interval from 1 to x. Then you can apply the mean value theorem. So that tells us that there's some number c between 1 and x that has the same slope as the secant line joining those 2 points with the green line. Okay, so that means that f of c is equal to f of x minus 1, the change in y, over x minus 0. That's the mean value theorem right there. But we're told that the absolute value of this is less than or equal to 1. And since this expression is equivalent to f prime of c, that also has to be less than 1. And then here's where we start using theorems on absolute value. The absolute value of a quotient is equal to the absolute value of the numerator divided by the absolute value of the denominator, as long as the denominator does not equal 0. And now we can multiply both sides of this inequality by the absolute value of x without changing the direction of this arrow because this is a positive number. So that gives us absolute value of f of x minus 1 is less than or equal to absolute value of x. But now we apply this theorem right here. I can rewrite the absolute value of f of x minus 1 and say that this expression, the absolute value of the first term minus the absolute value of the second term, is less than that. And so I can just compare these two right here, which is what I've done on this row. And now all I need to do is add 1 to both sides, and I've got the absolute value of f of x is less than or equal to the absolute value of x plus 1. There you go. QED, that which was to be proved. Okay, that's sort of messy. Hopefully you can pause the video, take some notes, and gain an understanding. But if you have any questions, go ahead and post a comment.